Okay, welcome back. We are still talking now control and the design of control systems. So, moving on to parts of it, right? So now having a firm foundation in, frankly, what is essential. Let's back up a bit by just for a minute, right? Now it's important to have a solid understanding of the difference between the two key outputs of the process we call plan scope management, which is the scope management plan and the requirements management plan. The process of plan scope management involves the creation of these documents, as we've talked about in the past, these two plans that describe how the project scope and the requirements will be defined, validated, and controlled. So now, as a rule, a well-designed management plan in the scope knowledge area is going to help minimize the chance of scope creep, which is any occurrence of uncontrolled scope change. They also help minimize gold plating, where the team may add features or functions to the deliverables in an attempt, to surprise or delight the customer. So I've said that's generally a good thing, but gold plating is always undesirable. You want to get the customer's approval before you surprise and delight them. Surprise and delight them through the planning and the delivery process, not by adding things that they didn't ask for. And you also, through this process, you want to help avoid scope gap. And you can look that up for further study if you choose. So scope creep, scope gap. Thus, these two management plans that we've talked about previously are created in this process called plan scope management, led by the PM and his or her team. Scope gap and scope creep are much more difficult to contain. For this reason, they're both unpredictable, and they are risks, since the basic definition of a risk is an uncertainty, right? So it ties into so much that we've been talking about through these weeks in this course, in our practical approach, management level approach to considering project management. So for the control of scope, cost, and time usually requires different input data, right? As, for example, engineering change notices or test results, quality checks, maybe rework tickets, scrap rates, and maintenance activities. Anyhow, all that ties to the scope creep, which we can manage in our work breakdown structure. Remember, we said in the work breakdown structure, if it's not in the WBS, it is not in our project, and that's going to help you manage scope creep. So for cost control, the manager compares the budget data, for example, to the actual cash flows, the purchase orders, etc. Maybe looks at income reports or cost exception reports and the like. And these controls can then tie back to the work breakdown structure, where you added up the costs in the control accounts of your work breakdown structure. We talked about that previously. And then you can do benchmark reports. Remember, I said reports are a good way to communicate with stakeholders. There's work performance data, work performance information, which is the analyzed data, and work performance reports, these executive summary one-page reports. So we might do benchmark reports or periodic activity reports, etc. One of the a good system, though, overall, though we want it to be detailed and accurate, still has to be flexible, has to be within your budget, has to be something the stakeholders, decision makers can use, etc. And I went over the rest of this list on characteristics of a good control system. Now, one of the tools that the book talks about, beginning on page 438, is a critical ratio control chart, or they just call it a CR, critical ratio. And this is the actual progress divided by the scheduled progress times the budgeted cost divided by the actual cost. So it's made up of these two parts, and it's a ratio of, again, actual progress to schedule and actual budget budget cost to control. There's a term they use in the book called ceteris paribus, Latin, and it is to quote an economist, every economist who ever lived, that the ratio of actual and scheduled progress, if it's greater than 1, is good. That Latin phrase meaning all other things being equal, right? Ceteris paribus. All other things being equal, in a ratio, if it's greater than 1, it's good. If it's lower than 1, you're trending in the wrong direction. And so through this, we can use, for example, another control mechanism is a control chart. A control chart is one of the 7 basic quality tools, and it uses this sigma. I got the symbol for the sigma there. And sigma means standard deviation. So notice the chart at the bottom, we have this acceptable range of variation between the lower control limit, the dashed line, and the upper control limit. And as long as all of our data points fall between our defined upper and lower control limits, we're good to go for the most part. And if we don't know how to define our upper and lower control limits, we might, as project managers, we normally use plus or minus 3 sigma or 3 standard deviations. Okay? And notice that on this, there's a rule of 7. A rule of 7 says, even now, if a data point falls above the upper control limit or below the lower, it's called out of control. And you want to do root cause analysis on that in your sense of control. But also, even though the data points fall between the upper and lower on this chart, if 7 data points in a row don't change direction above or below the mean, that's the average line in the middle, then you also want to do root cause analysis. That's the only exception. Here is a picture of how it looks. So we have our lower control limit and our upper. Any data point in there is considered normal variation or normal distribution. We're okay with that. It's fine. But and that's acceptable. And if we don't know how to define it, we could just use plus or minus 3 standard deviations we talked about. Notice the customer can set a limit. That's called on the bottom right, the specification limit. What have they specified? And I would make my lower control limit just above that. Now, anything that falls below the lower control limit or above the upper control limit, you see in the top right in red, that's called out of control. And we want to assign a special cause code to it. We want to investigate why. Anything within the upper and lower control limits is considered normal. We accept it. There's only one exception to that, and that's the rule of 7 we just talked about. And you notice I've got the 7 data points on the left-hand side of the chart. They're still within the upper and lower control limits, but they're not going above or below the mean. So that's a problem, and we want to check that out. Now, I talked about sigma. What's that mean? This is really what it means. If I want my project to be minus or plus 1 sigma from the mean, from the average, that means that I am looking for 68% of my data points to fall within plus or minus 1 sigma. Right? If I'm building a dollar store flute, that may be good enough. If I'm building the space shuttle, I want 6 sigma. So if you look at the bottom, what 6 sigma really means is that I'm 99.99999, etc. percent sure that all the data points will fall where I want them. That means I'm going to have about 2 errors out of every 1 million outcomes. That's the kind of space shuttle quality we're looking for. But I don't need that much quality, that much control in a dollar store toy. So we can benchmark then these various approaches that we use, right? This is something else you can add to your arsenal, right? We can make comparisons or benchmark. What is best in class and how does ours rate to theirs? What are the practices in the organization or even across the industry? So it's a good way to go. Now, as I mentioned, we do want to control change and scope creep, right? In earlier chapters, in fact, we discussed that the original plan for the projects are almost certain to be changed before the project's completed, right? It's progressively elaborated. We're a little uncertain about the technology, about the increase of knowledge, about the modification of rules. And so we plan in detail, but we expect changes along the way. So that happens. So the most common changes are due to the natural tendency of a client or a project team to try and improve the product or service, right? Better requirement, which means we could maybe do better requirement solicitation along the way. But either way, we'll make the changes as needed. Agile is useful in this because it involves the decision maker also along the way. Now, we do want a formal change process, which is an excellent way to go. It will help control scope creep, a formal change process where we document everything. We make sure the experts are part of the change process, that they've signed off on it, that maybe we did a peer review before the change was presented, that we tested the change before it went to the board in various environments, right? Maybe we built a prototype or a method or a model, and that we're communicating it, whether the change is accepted or rejected, etc. So, so we're concerned even about the change order that things happen. If the project is large, you may even want to have a change control board as part of your change control process. So there are guidelines for effective change control listed here on the slide. I also want a functional expert to review the change and to comment on it during the review of the change board. Now, change is inevitable, and so to me, there's a lot on this slide. You don't have to read it all, but notice a couple of keywords. Integrated change control is, so when I have a change to my baselines on the far right column, if my baselines are good, I don't need to go to change control. But if they're off, if there's a variance, if there's a gap, we want to go to change control. So I'm going to have an integrated change control board. All of this on the right-hand side in red, I have CCS. This is my change control system. So I want an overall system. So if my baselines are off, I'll go to the integrated change control. I'm going to refer to my change control system on how I'm doing that, which is going to include a CCB, a change control board. And the results of the board, which I'll have a functional manager, my sponsor, myself, I'll do the work performance reports. We'll discuss it. I will communicate it to the other stakeholders and, of course, implement it. Now, here is a kind of a summary slide as a project manager from the perspective of control, that I want to prevent the change from happening. But if they're going to, I want to identify the potential changes. I want to assess, analyze the impact of that change. Then I will do a formal change request, which will send it via the ICC, or the Integrated Change Control process that was on the last slide, using my change control system in a change control board, right? There's going to be a result, which is going to be accepted, partially accepted, deferred, rejected, whatever. I'm going to update documents, and I'm going to communicate that to stakeholders essential to change. Okay, and these are controlling creative activities as reviewed in the literature on page 446. Process review, personnel reassignment, control of input resources, skill levels, etc. Okay, I've enjoyed this. Hope you did too. Let's go back to the discussion board and everything else on this week as we get ready to round out the course. Thanks, everybody.